Welcome to the third day of the Subnet Summit series. Today we have Leo Chokroun with us, and Leo is at Ash, this company that is working to build an open source toolkit to empower subnet owners, developers, and node operators. Just as a bit of a background, Leo's company, after they worked 5 years as data consultants, they created this company called E36 Knots, which is building Ash to empower the Web3 ecosystem with their 5 years of IT infrastructure knowledge. So today they're going to be discussing their first tool, which is an Ansible-based Avalanche repo, which leverages Ansible. Some of you know Ansible is the de facto tool for IT automation, and it's going to be used to manage the entire node lifecycle in Avalanche validators. So welcome to the summit, sir.
Thanks, Nathan. Thanks for having us. As I said earlier, it's a really cool event. I watched most of the event so far and got some great insights from it. So thanks for hosting this, and thanks for having us.
Well, wonderful. Yeah, we're all building up to the Avalanche, Barcelona Summit. So we give them a massive plug. If anyone would like to go, their tickets are still on sale, although they're slowly decreasing. So yeah, I'd love to learn more about Ash and see some of the demos and learn about how your infrastructure provides support for the ongoing, subnetwork.
Yeah. Okay. So as you said in the beginning, some agenda. I have a couple of slides, but should not take us too long. And most of my time here will be spent on a technical demo, which will showcase everything we can do with the Ansible Avalanche collection that we built. So quickly about us, as you said. Our company is called E36 Knots. We have a background of being a big data IT experts. We worked for most of France's biggest company operating big data clusters. And we started getting interest in Avalanche about 2 years ago with a colleague. And so we decided to create a company and to build our first product, which is called Ash. Which will be a set of toolkits around to empower users and developers around the Avalanche ecosystem. Okay, I think I skipped the slide. Okay, so there's the mugshot with lots of smiles and great shirts. So this is me in the middle, and these are my colleagues and co-founders, Gauthier and Antoine. So for a little bit of context, we, as I said, we started getting interest in Avalanche about 2 years ago, and we went to the Avalanche Summit last year. We participated with my colleague Gauthier in the hackathon that was organized there, and it was a fun experience. And at this time, we had some chats with the other teams, and we did notice that the biggest pain point of the other teams were around deploying the Avalanche Go software, creating subnets. The documentation from Avalabs at this point was not what it is today. They had some great improvements on this side, and this is actually around this time that we started working on what I'm going to show you today, the Ansible Avalanche collection. So in terms of the subnet infrastructure problematics that we identified during this hackathon, it started with the Avalabs tooling. So in case there's some guys from Avalabs watching us, this is absolutely not this. We love your tools, we love the tools, but we did notice that they are a little sparse. We have Avalanche Go, Avalanche Network Runner, Subnet CLI. There used to be the Avalanche CLI, Avalanche JS, which are both deprecated, if I'm correct. We did find that these tools were a little bit hard to integrate with other solutions. It's some light stuff, like for example with the Subnet CLI, when you create a local subnet, you have no other choice but to run a local subnet that's running with the default Avalanche network runner properties, like the default ports, the default properties for Avalanche Go, etc., which is a bit annoying. Also, the Subnet CLI, you cannot exploit the output of the command in the JSON form, for example. It's it's little things like this that got us bugged and made us want to bring something to the table. Also, when it comes to the famous Avalanche Go installer.sh, with most, if not everyone that did deploy Avalanche Go at some point had to use, we think that is great for getting started, but it does not scale well to having multiple nodes. And also in the node as a service ecosystem, we did find that most of the providers, I mean, they're great. They're doing a great job. We did try a bunch of them. I watched the talk yesterday with Nirvana Labs. What they're building is super cool. But we did notice that most of these solutions, they seem like software as a service black box. Like, you don't really know much about what's going around you. You basically, you put your credit card and you get an Avalanche node spin up. You get an RPC so you can interact with it, but you don't really know what's happening behind the scene. And with these services, there's no possibility of self-hosting your nodes. Like, you cannot bring your cloud or bring your machines. And also, some of these services have a lack of native integration with Avalanche main feature. That's interesting here for us in the summit, which are subnets. And so this is how we came up with the Ansible collection. Just to introduce Ansible to the people that don't know what it is. It's an open source IT automation tool, which has been developed by Red Hat. Actually, it was bought by Red Hat a couple of years back. And it has become the de facto tool to automate system configuration and software deployment. Our background as a big data engineer, we used Ansible almost daily because it was our job to deploy software on lots of machines in a reproducible and predictable fashion, which is exactly what Ansible does. And so we thought that we could leverage Ansible capabilities to operate Avalanche node clusters in a large scale way. And so we came up with the Ansible Avalanche Collection, which is open sourced. You can check it on our GitHub. Actually, credits to my colleague Gauthier, which did most of the groundwork of everything that I'm going to show today. Today we're working together on this, but it did most of the early works. This Ansible Avalanche Collection will allow us to deploy and configure a lot of stuff related to Avalanche. Obviously, Avalanche Go. So with the collection, you can provision Avalanche nodes on Fuji, mainnet, or even as a local cluster. The collection allows you to upgrade both VMs and Avalanche Go, which we'll be seeing in the demo next. Ansible brings us easy node configuration, persistence, and idempotent deployment. This is really important because if I have some test infrastructure on Fuji and some production infrastructure on mainnet, I want to make sure that both of them look the same, and Ansible is great for doing that. With the collection, we can bootstrap local networks, as we'll see next. And we also implemented a bunch of cool features related to Subnet, so it can be used to create Subnet, create blockchain, and also some extra feature like creating Faucet, creating a block explorer that's directly connected to your Subnet, and more to come.
Okay, now that is super cool.
Yeah. And yeah, also a lot more features that will be.
So for folks who don't know, I'd love to dive into just the block explorer part. So when you're bootstrapping a new chain, you have to index everything, and you have to create your own customized indexer. So the fact that you have a out of the box block explorer is super cool. I'd love to go into that whenever you like.
Yeah, but we'll see that in the demo. Where actually we can go to the demo right now. So during the demo, what we're going to do, we're actually going to showcase the the tutorials that we did for our website. You linked the documentation earlier. We're going to install a 5 nodes Avalanche cluster on virtual machines, which will be running on my computer for the sake of the demo. And we'll do a bunch of stuff on this Avalanche cluster. We can deploy a subnet, a blockchain, try to deploy a Faucet and a block explorer, and also see how the Ansible collection can help us perform Avalanche Go upgrades. And of course, answer questions. Feel free to interrupt Nathan at any time if you want to dig more on something.
Okay, sure. Yeah, I encourage people listening on audio to check out the broadcast on YouTube.
Yeah, this is going to be hard to follow with audio only. So I will now share my screen. Entire screen. Should be fine. Let me know if it works. Oops. Can you see my screen properly? Or do I have to activate the share in this? Oh, I think I lost you, Nathan.
Sorry, yeah, it worked before. Now we're tiled. We had your terminal before.
Oh, sorry. Do I have to do something on my side, or is
You just
it on
have
you?
to. You have to choose the right screen. You're still choosing your browser.
Okay.
There you go. All right. We're good.
Okay. So what I did before, just before starting the talk, is that I did create a couple of virtual machines on my computer using Vagrant.
Also, you may want to zoom in a bit.
Okay.
There you go. Cool.
Okay. So I did use Vagrant to create some virtual machines on my computer with VirtualBox. Actually, I can open VirtualBox to show you how it looks like. I have 5 small virtual machines with 1,000 gigabytes of RAM running Ubuntu on my computer. Actually, yeah, just as an introduction, everything that I'm showing here is actually the docs from our website, which are right here, ash.center/docs.
I'll show them.
Everything is all of the comments that I would be doing are actually on our documentation. And so in this first part of the tutorial, what I did before the call was creating the virtual machines. I did this before because it's a bit long and not really interesting for our viewers. So basically now what we can do is show what an Ansible inventory looks like. I will zoom in a bit also. Tell me if the size is okay. I think it should be fine. So basically what an Ansible inventory is just a list of nodes. They could be VM, they could be bare metal machine, they could also be Linux containers. These nodes will be reached via SSH with Ansible, and then Ansible will perform a bunch of stuff on these nodes. What Ansible performs is what we describe in the Ansible collection. For example, create a user, create the right directory, upload an archive, extract the archive, etc., etc. So what we want to do in our inventory is to define a group, an Ansible group, which will be where we will be installing Avalanche using our collections. So in our case, the group has to be called Avalanche nodes. And here I'm going to be putting all of my 5 local virtual machines. I nickname them from validator 01 to validator 05. And all of this IP address will be resolving to virtual machines on my computer. In the case of this demo, we'll be running a local Avalanche network, not Fuji or mainnet. So we have an extra step in which we have to define a bootstrap node. In our case, the bootstrap node will just be validator number 1. Again, all of this is described in our documentation, which you can see right here. Okay, so I'm good to go. I define. I have in my inventory my 5 VMs, and I tell Ansible that these VM are part of the Avalanche nodes group, which will be targeted when I run the Avalanche playbook right now. Okay, so this command is basically, I'm running an Ansible playbook, which is a series of action described in Ansible. And I'm asking Ansible to run the Bootstrap local network playbook on the inventory/local inventory, which is the one that we just seen right now. Okay. And so there we go. Now the magic happens, and everything that's needed to deploy Avalanche Go on a machine is now being deployed on my virtual machines.
Okay, and these, just as a point of, these virtual machines each are 1,000 gigabytes on an external hard drive?
They're running on my computer right now. I can open a new tab, use Vagrant to SSH into one of the machine.
But this machine you
there I
said
am.
has 1,000 gigs of storage?
No, in RAM.
Oh, just RAM.
Yeah, no, it's actually 1 gigabyte. Sorry.
Okay.
Sorry.
Okay,
Yeah.
good. Okay, there we go.
My bad. Yeah, there we can see it with the free command. Yeah. Sorry.
Okay, cool.
Sorry for the confusion. So there I am inside my VM, the first one, validator 01. And as you can see on the side, a bunch of stuff is happening. I will show you the first steps and just to explain what's going on behind the scene. So the first thing that we'll do is create an Avalanche group and an Avalanche user, which will be the one that will be running the Avalanche Go process on the virtual machine. Then we create a bunch of directories that will be used by Avalanche Go. In our case, we're deploying everything in this directory. I can navigate to it on the virtual machine and see everything that has been created. Okay, so there I am in OPT Avalanche, Avalanche Go. All of this is configurable, of course. There I can see that I have Avalanche Go in version 1.9.16. This has been defined in this YAML variable file, and all of this is configurable. So in my case, I'm running Avalanche Go in this version on a network ID that is local. This variable can also be Fuji or mainnet, depending on what I want to run. For now, I'm not installing any VM, so no Subnet EVM for now, or Spaces VM, and I'm not tracking any subnets. We're going to do that just in a second. And these are some variables that I have overridden, sorry, for a node. In our case, we have to adapt the Snow consensus protocol to a 5-node network, so I did configure these two parameters. And so what's interesting is that from this YAML variable file, our Ansible collection will template the right configuration at the right place. In our case, it's happening in etc avalanche go. In the config subdirectory, I can see my node.json configuration file. And if let me open it with Vim. For example, the two configuration that we just seen, snow sample size and snow column size, they have been added here as they should be. And all of the other configuration have been templated from the context of the run. So for example, the HTTP host and port, the port is coming from a variable and the host is coming from the IP address of my current machine. This is where I'll be storing my Avalanche Go database. If I have subchains configuration, they will be stored here, etc., etc. So I think our first playbook ran until the end. So now I do have on my computer a 5-node local Avalanche cluster. So right now it's not doing much because I do not have created a subnet. I have not run any transaction, etc. So let's go ahead and try to do that. First thing we're going to do before creating a subnet is installing the Subnet EVM, because out of the box we do not have it. So I will do this by simply.
Okay, so before we go into EVM land, these are basically blank subnet settings with no virtual machine set.
Yeah, exactly.
Right.
This is a vanilla Avalanche Go deployment with absolutely no virtual machine. And so right now, the only networks that are running are the P chain, C chain, and X chain.
Right. Okay. So for like to think about this sort of stage here, you could also choose like Hyper SDK, right, rather than the Subnet EVM.
I could choose any VM that is compatible with Avalanche Go.
Okay, so we could use here's where we would insert the Landslide core.
Yeah,
which is not EVM based; it's WASM based.
exactly. This is where you would put it.
Or for instance, SparkNet or
yep,
yeah.
any VM. We did that. We did that Spaces VM and Blob VM at some point in the tutorial, but we removed them recently because they were not really kept up to date by the Avalanche team.
Cool.
So in our case, we'll be wanting to deploy Subnet EVM in the version 0.4.12, which I think is the latest compatible with this version of Avalanche Go. We actually do keep a compatibility matrix of every known VM for now. So basically just Subnet EVM and, as I said, Blob VM, etc. But we definitely at some point will implement you guys' your VM and implement it in the collection. Yeah, definitely. So I just added this variable from an NT array to this list, and by relaunching the provision playbook, we will see that the VM will be downloaded and installed at the right place on all of my virtual machines. So actually, the playbook that I will run now is provision node, which is just rerunning the configuration. So most of these actually is okay because Ansible, as it's idempotent, it does not have to run something that's already in the state that we want. For example, as I said earlier, we create a bunch of directories, like for example the database directory, etc. All of these are already created because I ran this playbook before, so it says okay instead of change. What should be changed though is the plugins directory. There we are. Oops, I skipped it. Sorry, it's a bit big. I'm having trouble to find what I want. Oh yeah, there we go. At this point, what is changed here is that we create a new directory to upload our Subnet EVM. We download the binary of the Subnet EVM in the version that we targeted, and it's being put at the right place in the Avalanche Go. So if I go back to my Avalanche Go directory installation, I can see that I have a new directory that's been created, which is called VMs. And in this VM, I will have a list of the VMs that I want deployed by the Avalanche Ansible collection. In our case, we do have the Subnet EVM in the version we want, and there's the binary. Also, what's interesting to note is that the collection automatically detected that something changed in the configuration. In our case, we added a VM. So it knows that it has to restart Avalanche Go in order to load this VM and take into account the new configuration that I just did. So Avalanche Go has been restarted. The VM has been read and is ready to be used in a subnet and blockchains. Okay, cool. So now that I do have my VM ready to go, let's go ahead and deploy, try to create a subnet. So as just as a warning, for now, how we implemented the subnet creation, we did use the key store API, which has been marked as deprecated in a couple of versions ago. So this is pretty, how can I say, maybe dangerous to use in production because it's from the beginning in the documentation, Avalabs recommended not to use this in production, and since it has been deprecated, it will probably be gone in a further release. So we do have some work to do to re-implement those in proper transaction signing and validation. So in order to create a subnet, I do have to create some control keys, which is actually done by this curl request. This is just a basic request on the pchain endpoint of my local cluster. And the payload is this. We do create some control keys for the user evoke, which is which should be familiar to those that have already went through the Avalanche documentation. So I will just run this. Well, let me close this one so we can see better. I will run this here. If I try to, I saved the two control keys in environment variables, so it should be key $key1 should be fine, yeah, and key2. Okay, there are my two control keys. Next step is to
Sorry,
run
just as a
Yep.
point, describe the importance of those keys and where they should be stored.
Well, those keys are the ones that are used to, for example, whitelist validators inside the subnet. So they are pretty important, and they should be stored. Not sure what you mean here, but I don't know, like the most secure way possible.
I mean, not in this particular demo, but let's say you're doing this in production. Where do you recommend storing those keys? Like
Not sure.
Dashlane, like some like.
In this, yeah, like most secure stuff. What we use on our side is we use a tool called Pass, which is a GPG encrypted password manager. You can also put them on a ledger, I guess, but thing is keep those secure.
Okay, so just describe the function of those keys once more.
Of the control keys.
Mm-hmm.
Well, they're the ones that prove that you are the subnet owner,
right?
And as I said, I think they are used to whitelist validators, if I'm correct.
So this, if these keys leak, that means you'll have potentially malicious validators joining the subnet.
Yeah. Okay, so we do have a control keys. Let's keep going and create our subnet. In the case of this command, I'm just overriding some variables to load the control keys that I just created. Again, using this using the key store API is not really recommended, but for the sake of the demo and local development, it's okay.
Just as a one final thought about the private key management, I suspect that at some point institutions will want to have those keys generated by a custodian, someone like an MPC provider like Fireblocks or BitGo or someone, because they need to have the keys kind of insured and managed. That's probably where that will go.
Yeah, I guess I haven't really thought much about this, but yeah, it's definitely something to be weary of as a subnet owner.
Yeah, that's like basically the keys to your house.
Yeah. Okay, so my playbook here did nothing because I forgot something. I forgot to add a subnet control node to my Ansible inventory. What will this be doing is just we give Ansible a target because most of the subnet creation step are reaching to an RPC node, and we have to define which RPC we want to join in our case. So let's just add one and put validate one. I will also add another Ansible group. In this case, it's the validators that will be validating my subnet. So I'm creating a subnet that's not validated by all of my local cluster, only validator 1 to entry in this case.
Do you need to have a prime number?
No, this is actually just in terms of Ansible host building, inventory building. This is just like an alias. It could be anything. I will go ahead and
I mean, like, can you run a subnet with an even number of validators? Does it matter?
I think we can, yeah. If there's no consensus, well, in case of a local cluster like we have here, if there's no consensus parameters are well set, I think there should be an issue in running an even numbered subnet.
Cool.
Okay, the playbook went through the end, and our subnet was created.
Yes.
Yeah, that's cool.
So that means we have a Genesis file.
Not yet. This is actually the next step.
Okay, so we have the subnet ID.
We just have the subnet ID for now, and as we can see here, the collection is reminding us that the subnet ID has to be on the track subnet list of our validators in order to be validated. Because if I go a little bit earlier, so at this point, the subnet was created, and we added the validators to the subnet. But for now, the validators have not been the Avalanche Go have not been told to validate the subnet. So we do have to go ahead and add this to the configuration. I will showcase it in another window. I can SSH, for example, on my validator tree, and go check out its Avalanche Go configuration. Node.json. For now, it's not tracking any subnet because this variable is empty. So what I'm going to do here is just get the subnet ID that has been created and add here, as I did for the Avalanche VMs, just a new subnet, which is basically the ID of the subnet that has just been created. I will go ahead and rerun the provisioned playbook. Again, all of this is already in good state, so all of this is okay. The only change that we should see here is the templating of the node configuration, which should be changed because we are now tracking subnets. Yeah, there we've seen it. Let me show you. It's this one, this part. Okay, we went to the end. If I go ahead and get my configuration file, I can see that my subnet is now being tracked with the right variable. And Avalanche Go has been restarted on this node because because the configuration changed. So now my subnet is created. I have 3 validators inside the subnet, and all of these validators Avalanche Go know that they have to track this subnet. So let's go ahead and create a blockchain then. Actually, I can just go to our documentation. In this case, I will have to override another variable because Ansible at this point, because we don't have a state, Ansible does not know about my my subnet ID, so I will have to give it to him through this variable. I will close this. In our case, the subnet ID is the one that I just tracked here.
I wanted to highlight a comment here. This guy on Luis Frima said, "Looks easier to add a validator than finding 2,000 AVAX."
It is. It is, and especially in our case because we're on a local network, so everything is free for us. Okay, so in this case, let's go ahead and create a blockchain. You were talking about the Genesis file. In this case, we have a pretty vanilla Genesis file, which I can show to you. It's inside the collection, I think. Yeah, there it is.
Would you just increase the size a little bit on that?
Yeah, sorry.
Thank you. Yeah, there we go. Great.
So this is all of the default variables that Ansible will use in the blockchain creation playbook. And so as I've not overridden anything, this will be the variable, the data that will be used. As I said, it's a pretty basic Genesis file. I think we just copy the one from the Avalanche documentation.
Okay, so for those who don't know, would you explain how you want to start token, maybe account balances here?
It's actually this variable. This is inside this variable, we can put some we can instantiate the blockchain with some tokens allocated to given addresses. This particular address is the Ewok address, as they nickname it at Avalabs, and this value is really high. I don't really remember how many tokens that is, But for development purpose, if I did want to spin up another blockchain based on the Subnet EVM with multiple addresses having balance, I could just go ahead here and write some other addresses with some value, and my blockchain will be created with the right balance for each of the users that will be here.
Right. So just as a point of clarification, what is the EWALK address?
The EWALK address is it's actually this one. It's the one they do use in the documentation as an example, because they provide both its public and private key, obviously. And I think the private key in the base 58 format begins with EWALK. This is why they name it like this.
Okay, so it's a fully doxed address, basically, right?
Yeah. It's everywhere in the Avalabs documentation.
Would you clarify? So, like, token balances. So, initial token balances. What determines those are a set of, like, let's say, early investors, a set of whitelists, incentivized testnet participants. What else determines those initial token balances?
Could be anything. If you for example, say you want to create a permission blockchain with only a dozen addresses that are allowed to interact with smart contracts, you could create your blockchain with an allocation of for all these 10 addresses and make it so that that only this address can interact with the contract. As you said, it can be some investors that will be having token in the instantiation of the blockchain. There are all other cases. It could be anything. I mean, like.
Great, thank you.
Did our blockchain creation went to the end? It did. And so at the end of the playbook that I just launched, the collection is showing us the actual ID of the blockchain. This ID is going to be useful to us because this is also the RPC endpoint of our Subnet EVM. In our case, it's this one that I'm going to save. I think I can then go ahead and try to create a faucet for this blockchain, which is going to be useful in terms of development, local development. Let me close this file. It's not needed anymore.
Those you don't know, faucets are where you get test tokens.
Yeah. Again, I'm just going to add another node to my inventory, in this case faucet, and I will put it on validator 01. So just to be clear, in this case, I'm reusing one of the nodes that I already have as a faucet, but I could totally decide to have another node in my Ansible host, which will be, I don't know, MISC01, etc. And this node could host all of the stuff that's not directly related to Avalanche Go, like my faucet and my blockchain explorer, for example, which is going to see next. But in this case, let's keep it easy and use validator 1 as a faucet. I do have a special configuration file for the faucet, which is this one. Yeah, I did not tell this, but the faucet is actually deployed based on the one that's been open sourced by Avalabs. So we just use this one and added some configuration that I'm going to show you. I do have to replace this RPC with the actual one that has been created for my blockchain, and I should be good to go. Let's customize theme here and give our special blockchain our subnet a nickname. It's going to be yours, Nathan subnet. And let's say the native token of my subnet is called the Summit. Okay, I'm good to go. And I will just run the Faucet playbook. Yeah, I think it's good. Let's go. This one is going to take a little longer than the others because to keep things simple, we are using Docker to create the Faucet instance and to launch it. So before actually configuring the Faucet and starting it, we do have to install Docker on the virtual machine, and then we do have to pull the Avalanche Faucet Docker image, which takes a bit of time. So maybe if you have questions or
Oh,
remark, maybe
I've
right
got
now
some
is the good
questions.
time.
Okay, so just as a, I am a very defensive-minded person. So if you go back and listen to the Dispel interview I did yesterday with Ian Schmertzler, Dispel provides moving target defense for like water systems, like municipal water systems, like Fortune 500 companies. And so if you're a paranoid person, I suggest going back to that. The reason I'm bringing this up is because um, is those P chain addresses that manage the validator set. That's like that's the central point of failure here. And I just bring that up because if people listen back to this, because it's going to be on YouTube or wherever, that they'll be able to know where that back door is. And so the responsibility that we have here is to say this is the danger point, is that if you leak your keys to that validator set, everything will go haywire.
Mm,
I encourage people to if you don't know how to manage those keys, reach out to someone who does. Like,
yeah.
I'm sure the team, Leo and Ash, can help you manage those keys. If you're an institution, you're probably not listening to this, but if you are listening to this, you have your own team that will talk to you about how to manage those keys. I suspect that, like, from the perspective of Ash, I think you guys should contact Copper. These guys do multi-party compute key sharding specifically for that,
Mhm.
and you just basically you form an API with that service so that those keys are managed by a multi-party compute system rather than your desktop.
Yeah, this is a really good point, and we were we talked about this earlier between us, and we were pretty sure that we'll have to integrate with
Yep.
some of these guys at some point. Yeah.
Yeah. Dispel would be happy to help provide that type of moving target defense system. So, like, what we did when we've deployed smart contracts in the past, we set up a virtual machine, like basically a secure moving target network. We set that
Mhm.
up, and we deploy all of these uh, uh, um, contracts and all of the repos in that safe VM, and then we store that key in a new generated wallet, and that's how we store it.
Yeah.
That's a pretty reasonably secure method to manage those keys.
Yeah.
The other piece I wanted to bring up was I would love to do this from within ChatGPT.
Actually never tried. I did use ChatGPT to debug some Ansible stuff for me,
If you have
but
a plugin to, like, if I would say that if you guys want a ton of users to set up subnets,
mm,
that's how you
it,
do it. You set up a plugin basically through like there's a couple tutorials out there,
yeah.
but yeah, that's the way to bootstrap these users.
Okay, that I haven't thought of it that way, but we we'll definitely check to see if we can do that. Um, so okay, so as we were discussing, that I think our faucets got spin up. So let's try to see if it's working. Um, Faucet should be running on the validator 1 node. So
Just
this is the IP.
increase the font on this one a little bit.
Oh yeah, sorry. This is actually the docs,
Great, thank you. Yeah, that's most important.
and there's my faucet. Okay. So we can see that the configuration override that I did put was applied correctly. Before requesting some tokens from this faucet, I will just actually add our blockchain, our RPC of the subnet inside my MetaMask. Um, I think that was when I did it before. I will just replace it. Ethereum networks. Well, let me do it in the expanded view so we can see better what I'm doing. Just copy and paste the RPC of the blockchain that we created and configure it inside MetaMask. Network. So that was my previous. I'm just going to be deleting this one and add a new network. So we say that this was Nathan's subnet. There's the RPC and the chain ID, I believe, is 13 to 13. Okay. And we say that our token symbol was Summit. So this is not really useful because it's just for showing in MetaMask.
Right on.
Okay, so we added the network, and I can see that I currently have 0 Summit. I will try to airdrop some for me using the faucet. So yeah, we were discussing about the EWOC address that comes pre-founded in our case. This is actually also the same address that we use as the faucet balance. So this is why the faucet has plenty of summits to be distributed. Did I pick? Yeah, this is my address. I will airdrop me to submit. Transaction went through, and I should be seeing my tokens pretty soon. Okay, here they are.
Nice.
So the faucet work, and as the faucet did perform a transaction, we're pretty confident that our subnet is running properly. So last step here, we want to have what we discussed in the beginning is the block explorer. So in the same fashion, we implemented the block explorer as a Docker service. In our case, this is block scout. So basically, the only variable I have to override again is the RPC endpoint. So I'm just going to go ahead and copy blockchain ID from here. Okay. So the RPC again is just the IP address of the virtual machine, and the blockchain ID is the one that we created together. And this will be the final playbook that I run. Block scout Docker, it's this one. Oh, okay. So again, it did nothing because I did not specify to Ansible on which target it should install block scout. Again, we'll keep things simple and deploy block scout to the validator 01.
And this indexes that?
Sorry?
That block scout indexes?
The block scout is actually the name of the Ansible group that Ansible will be targeting to deploy block scout. So this is an arbitrary name that we choose because we are using block scout as a block indexer. Yeah.
Okay. So
we did look at some other open source block explorer. I don't remember the name. But yeah, in the end, block scout was working better for us in terms of integration with Subnet EVM. Okay, should be up in a couple of time. Actually, in the meantime, I did not show you this, but what I can do is go back inside the VM and show you that okay, block scout has just been started, and actually the faucet is this one. It's running as a Docker service, and so is the block scout service.
Congrats, you did it.
Let's see if we can access it. Yep, there we go.
Yeah.
So what I just did was actually I pre-configured the faucet so that it knows about our block explorer. So this is actually the transaction from when I requested the 2 Summit token into my address. So if I click here, this is the block scout that's running locally and configured on our Subnet EVM blockchain. So we can see that
there it is.
our two subnet transaction from the faucet address, which is again the ewok address, to this dev address that I created for this talk. And we can also, oh, what happened? Okay, demo effect, obviously. So this is the,
Just increase the font size a little.
Yeah, sorry.
Yeah, there you go.
Oh, this gets a little bit messed up in terms of CSS, but I think we get the gist. So for now, I only have one transaction. Maybe I can try to perform an internal transaction to see if I can see it indexed. Actually, we just send back these two token to the ewok address. Well, not the two, because then because of gas, I will not have enough. So I will just send back one submit token to the faucet address.
Right on. We've got about 5 more minutes. Are there questions from the viewers, either on Twitter or YouTube? Just if you're on Twitter, throw up a hand. If you're on YouTube, just put it in the chat.
Yeah, maybe as before we close, so again, all of this is open sourced and on our GitHub. All of the documentation is on our website. But one question that people might have is why we're doing all this, because all of this is open source and free to use. So not much money that we're making.
I had that question myself.
Yeah, this was actually our last slide. I will just stop sharing my screen and go back to the slides. If
I'll get the slides for you.
Yeah, thanks.
Mm-hmm.
So what we're trying to build with this is actually what we call the Ash console. To sum it up, is we just want to make subnets more accessible and decentralized for everybody. And so we're building this enterprise-grade toolkit to develop subnet and operate Avalanche nodes. So what we'll be doing is based on everything. All of what I just showed you today is already open source, and we're trying to build some kind of web UI that's built on it to allow developers and subnet developers and Avalanche node operators to have more control on their infrastructure, and having some kind of production ready tool, as it's been said in the comments. So this is what we are trying to build for now.
Awesome. Just as a point, where does Ash turn on the money machine?
Well, we'll have some, as I said, we'll have some, maybe we can say like a SaaS web UI, which will ease everything that we've seen, because we are familiar with Ansible and CLI and commands, but we know that people want some shiny web UI and buttons to click on.
I want the GPT version. I don't want
and the GPT version. So basically, what we'll be selling is the web interface to manage what we've seen in a much more user-friendly way, if I can say.
Right on.
And some premium features as well, like automatic node upgrade every time Avalanche releases a new Avalanche Go version. Some advanced monitoring using Grafana and Prometheus. We have a bunch of premium features that will not be entirely open source, and that we hope to be selling as premium plans, and of course support on all of what we're building.
Well, happy to have you. This was great. As you know, it's super cool to see this all happen in under an hour. That is the 5-minute hello world. Let's see if we can bring it down to a a 5-minute hello GPT. Here's my subnet. But this has been great. Leo, thank you so much for your time. I'd love to schedule another session with Ash where we can do a 5-minute install, see if we can get it down there.
Sure.
Anyone can reach out to you on Twitter. Why don't you give me your Twitter and I'll post it here.
This is the latest slide. We do have some Twitter, and we just set up a Discord. If anyone has trouble or want to get help getting started with the Ansible collection, feel free to reach out to us, whether it's issues with GitHub or on our Discord or even on Twitter. We're
All right. Thanks, man. I appreciate it. Thank you so much for coming.
Thanks for having us, and
Yes.
have a last good day of sessions.
Cheers.
See you.